This is a worked example on how to show a function is one-to-one and then how to find its inverse. So it might seem a little arbitrary why we want to show that a function is one-to-one, but the reason we do this is because a function being one-to-one and a function having an inverse are actually equivalent statements. So, excuse me, if a function is not one-to-one, then you don't need to waste your time looking for an inverse because you know it doesn't exist. So let me really quickly write the definition of one-to-one. So if you have a one-to-one function, that means that if f of a equals f of b, then we know that a equals b. So how we want to set this up, and I'll use some colors to demonstrate, is we want to set up f of a equals f of b, and then show that from that we can deduce that a actually equals b. And so all we're going to do for f of a, so let me write the definitions, right? F of a, we can write 6 times a minus 2, and for f of b, we can write 6 times b minus 2. And let's set this up in an equation, right? So I'll say that 6a minus 2 is equal to 6b minus 2. And now we want to show that from this, I can find out that a equals b. And hopefully this is pretty clear, right? I can add 2 to both sides, and these cancel. Then we get 6a equals, and I'm balancing my colors here, 6b. Then we can simply divide 6 from both sides. These cancel, and we're finally left with the statement that a equals b. And so this function does satisfy the definition of being one-to-one. And so that means that this function is going to have an inverse. So with this newfound knowledge that my function has an inverse, we can then use this following set of steps. To find an inverse, you want to write the function as y equals the function. So you want to drop the f of x terminology for a moment. Then you want to swap every instance of f of x with each other. So every time a y shows up, which will only be once most of the time, then you're going to put an x. And anytime you get an x, which likely will be more than once for more complicated functions, you can say 6y minus 2. Now we want to solve back for y. So we want to isolate y, and this should give us an inverse if we do everything correctly. So I can start by adding 2 to both sides. Then I will divide 6. And now that I have y isolated, this is the definition of the inverse function. So I can write this as f inverse equals x plus 2 over 6. And if you're really unsure if this is correct, you can always check by doing the composition. I should be able to verify that f of g, not f of g. I should be able to say that f composed with f inverse of x equals f inverse composed with f. So if that definition is satisfied, and I kind of ran out of room towards the end there, but as long as this is satisfied, then we'll know we have found the inverse. I'm not going to do this in this video. It's a good exercise to work on if you are still confused. But this is a process of finding, first of all, one-to-one, and then finding the inverse of a function.